Hello everybody. So in this lecture we will discuss about Monte Carlo simulations. Now, Monte Carlo is simulation is a probabilistic approach, and it is mainly based upon random sampling. And when we create a uniform distribution of random numbers, for example, if you would like to find out random number between 0 and 1, so it can be anything between 0 and 1, and the numbers distribution, we create a sample size, that is how many numbers we would like to have, and according to that there is a uniform distribution between this range. Now there are different types of Monte Carlo simulations. Like one of them is called Metropolis Monte Carlo simulations. Monte Carlo simulation is mainly associated with thermodynamic equilibrium thermodynamics, and it is used in finding out the stability of phases in different conditions. The next one is the kinetic Monte Carlo simulation. It is a time-dependent process, and all the physical phenomena that are taking place which have relation with time can be associated with this kinetic Monte Carlo simulations. Lattice Monte Carlo simulation is where we discretize the structure into grids, and by grids we assign certain atoms to those grids, and we try to find out the atomic interactions. It is mainly used in spintronics, and we also have something called continuous Monte Carlo simulations, which mainly deals with complex fluid flow, and it is used in polymers and nanoparticles. Now, for to start with, we have considered a very simple example where the use of Monte Carlo simulation can be understood by using Python codes, and we have taken the vacancy concentration as the first topic. Now, the concentration of vacancies CV is equal to e to the power minus EV by kT, the relationship between temperature and the concentration of vacancies. Now, what we have done initially, we start with the first symbol, that is we bring in this numerical numerical computing ability of the Python. We call that import numpy, and we assign it a simpler term as np. Then we we assign the number of samples. We decide that how many samples which we shall be dealing with. So more is the least number of samples, the more is the accuracy of the program. So we have taken about 1000 samples, and then we have defined this Boltzmann constant, and the temperature which we are taking into consideration is 1000 Kelvin, and there is a energy of vacancy formation, that is 1.5 electron volts. These are the defined parameters. Now from here we start the Monte Carlo simulations. As you can see, the samples have been assigned a random number n. Okay, so that means the value can take any number between 0 and 1 multiplied by 1000. So if we take 0.2 for example, so it means that the number of samples here is 200. Like that. Now, probability of vacancy, as previously told, as is related to temperature, with this vacancy energy. Yeah. Now, the vacancy concentration is again taken as another command that is called the mean. You can see another command mean has been used, and the sample have been taken as which were initially randomized. These samples were taken as less than the vacancy probability. So if these samples, this is considered to be less than the vacancy probability. And then we find out the vacancy concentration. So the vacancy concentration is the mean of all the vacancy, all the samples which are below the vacancy probability. That's all. So it gives you the vacancy concentration at 1000 Kelvin. So which is ultimately found as 3.46 e to the power minus 4, which is 0.0346.